Hello, this is Mr. Huber, and in this lesson we're going to look at linear equations in point slope and standard form. We've seen slope-intercept form, y equals mx plus b. Now we're going to see those other ways we can represent the equation of a line. First we're going to look at point slope form. Point slope form is called that just because of what we use to write it, a point and slope. Like slope-intercept, we're still going to need to know the slope, but now we can use any point that's on the line. Right? Remember, slope-intercept form uses a very specific point, y equals mx plus b. That b is a very specific point of the line. Well, we might not always know the y-intercept. It might not always be that important. So this way we can use any point that's on the line and its slope. Again, note, still the slope is an important piece to this. And any point on the line, okay, any point on the line we'll call our x1 and y1. Okay, that just represents the x and y values. And it's going to go in here, y minus y1, x minus x1, and then we've got our slope still here as the m outside the parentheses with the x minus x1. So we're going to see how this looks to write it, how we can actually use this to turn it into slope-intercept form as well. Okay. So this first example, okay, we're going to write an equation in point-slope form of the line that passes through the point negative 3, 1 and has a slope of 3. So if we want to write the equation of this line, okay, we're going to have y minus, our y1 value is the 1 here, y minus 1, equals, and then we'll have our slope m, and then x minus, right, our x1 value here, which is negative 3. So we could write that as y minus 1 equals, for the m, 3, and then x plus 3. Right? We see our slope over here, slope of 3, so that's where we put in this slope of 3. Right? Keep in mind it's y minus y1 and x minus x1, so pay attention to the signs of the numbers if you're subtracting positives or negatives and how that goes. Okay, so our point slope form for the equation of this line would be y minus 1 equals 3 parentheses x plus 3. And we can relatively quickly change that to slope-intercept form by distributing this 3 into the parentheses. And if we do that, we'll do the work up here. We can get y minus 1 equals 3x plus 9. And then if we add the 1 to both sides, we get y equals 3x plus 10. This is that slope-intercept form we've seen, y equals mx plus b. Our slope's still 3. Now we'd have the y-intercept of 10 if that was useful for some reason, but we didn't need it to start this out. We didn't need to know the y-intercept. We used any point that's on the line. Okay, so let's see another example here where we have a graph that we're going to work from. Write an equation of the line in point-slope form and slope-intercept form. Okay, so let's start with the point-slope form. In order to write point-slope form, we have 2 points. We're going to be able to use either one of those we want, and we're going to need the slope. So let's figure out what the slope is going to be for this line. We go between these 2 points. We're going to go up and over. So we're going to rise 1, 2, 3, 4, and we're going to run 2. So our slope is 4 over 2. Okay, our slope is 4 over 2, which is 2. Let's use this point now to write our equation of the line. If we do that, we're going to get y minus a negative 3, so it's y plus 3, equals m, which is 2, x minus 1. So that would be the point slope form using that point 1 comma negative 3. Now let's write it using 3 comma 1. Okay? So if we do that, we're going to have y minus 1 equals, still a slope of 2, x minus 3. So these are both equations of this line in point slope form. Those would both be acceptable equations for this line. If we want to turn it to slope-intercept form, again, we can distribute the 2 into the parentheses here. We'll do that one first. We'll bring it over here. We're going to have y plus 3 equals 2x minus 2. And if we subtract the 3 on both sides, we're going to end up with y equals 2x minus 5. If we do the same process to this other point slope form, we're going to get y minus 1 equals 2x minus 6. When we add the 1 to both sides, we're going to get y equals 2x minus 5. Okay, you'll note, slope-intercept. There's only one possible way to write the slope-intercept form for the equation of a line. However, there are more than one way to write the point-slope form. So right here, point-slope form, using this point, 1 comma negative 3, y minus negative 3, so y plus 3 equals m, right? We calculated the slope, rise over run, which is 2, and then parentheses x minus x1, so x minus 1. And then turning it to slope-intercept form by distributing the 2 and then subtracting the 3 on both sides. And if we use this point here, 3 comma 1, we get this point-slope form again. This point slope and this point slope are both for the same line. They look a little different because we used a different point, but both the same slope. And again, after we write this, if we turn it to slope-intercept form, now we get the same equation for this line in slope-intercept form. All right. Let's take another opportunity here to write a point-slope form where we've got 2 points, not on a graph, but just 2 points that are given to us there. So we're going to still need to calculate the slope, right? We're going to have to calculate the slope using our equation for slope. M equals, and we're going to subtract the y values, 1 minus negative 2, right? Rise over run, 12 minus 6. So that's 3 over 6, which is 1/2. So our slope is 1/2. And if we want to write the equation in point slope form, okay, point slope form, let's use this point first. We'd have y plus 2, because it's y minus negative 2, equals slope of 1/2, and then parentheses x minus 6. Right. And now if we use this point, we're going to get y minus 1 equals 1/2, still the slope, x minus 12. For both of these, we can turn these into slope-intercept form by distributing. We're going to distribute a fraction here. That can be a little more challenging, but not too bad. 1/2 times x is 1/2 x. And 1/2 times 6 is half of 6 is minus 3. We subtract 2 on both sides, and we'd end up with y equals 1/2 x minus 5. Okay, so there's our slope-intercept form. And if we do the same process into that second point slope form, we get y minus 1 equals 1/2 x minus 6. Add 1 to both sides, we get y equals 1/2 x minus 5. Same slope-intercept form again. Okay? Again, point-slope form, you don't have to do this for every problem. You just want to know how to write point-slope form. Okay, if you're asked to write an equation of this line, you could use this here in blue or this one down here in green. Those are both equations of the same line in point-slope form. If you want to write slope-intercept, again, here's one way we can do it. Using the second point slope, second way again, distribute the slope into the parentheses and then get the y by itself. So you get it as a y equals mx plus b. All right. Let's take a little break here for some tentacle trivia. What's the plural form of octopus? You'll often hear people use the word octopi. It's actually not correct. Octopi would be the form plural if you had a Latin word, not a Latin verb, a Latin word. But octopus is derived from Greek. So the Greek plural is octopuses. So that's something you may hear often is mispronounced, octopi, but octopuses, because it comes from Greek, is the actual correct plural form of octopus. All right. Let's look at standard form. Okay, standard form is what we see right over here. ax plus by equals c. A, b, and c would be some values, okay? Some integers, fractions, negatives, they could be anything, okay? The only thing we don't want to have is a and b are not both 0. If a and b were both 0, we'd end up with 0 times x and 0 times y. That would just come out to 0 equals c, which wouldn't make sense, okay? So we have to have at least one a or b being an actual number, non-zero, okay? When we look at standard form, one of the things we're going to find is it's really useful for graphing linear equations and getting the intercepts. Okay, so it's important to know we can use this for graphing in the intercepts of the equation. Let's talk about what the intercepts mean for a linear equation. If we talk about the x-intercept, that's a point where the graph goes through the x-axis. So let's say this point right here, or this point right here. Any of these points I'm drawing in red would be x-intercepts. Those are values that are on the x-axis. Okay? You notice the coordinates for those points, if I wrote them down here, this would be -5, 0. This would be -3, 0. This would be 1, 0. 4, 0. You notice they all have a y value of 0. The x-intercept will always have a y value of 0. It's always a point right on the x-axis. It doesn't move up or down any y value other than 0. If we talk about the y-intercept of an equation, and you've seen these before, but these blue dots would be points that are y-intercepts. Okay? We use those when we graphed our y equals mx plus b's, and we started to see that in some instances. What we want to recognize here is that these will all have an x value of 0, 0, 5, 0, 4, 0, 2, 0, -4, right? Every y-intercept will have an x value of 0. So we're going to use this to help us find the intercepts, which then are useful for drawing the graphs. But keep that in mind. One intercept will have the other value of 0. So an x-intercept will always have a y value of 0. A y-intercept will always have an x value of 0. So let's see where we can use that by determining the intercepts of this equation. This is an equation in that standard form. This is the ax plus by equals c form. Okay? And so if we want to find the x-intercept, let's say, the x-intercept will have a y value of 0. So that means we can put a 0 in for y into that equation. So we're going to have 2x plus 6 times 0 equals 18. That's just 2x equals 18. Because 6 times 0 right here is just 0. So 2x plus 0 is 2x. And now we can divide by 2 on both sides and get the x-intercept of 9. Okay. The y-intercept is going to have an x value of 0. So 2 times 0 plus 6y equals 18, which is just 6y equals 18. And then if I divide both sides by 6, I'll get y equals 3. So if we wanted to write coordinates for that, it would be 9, 0. This would be 0, 3. We would know those would be points that are on that equation of that line, that are on the graph for that equation. Okay, right? A y value of 0, an x value of 9 gives us the point 9, 0. An x value of 0, when we put it in the equation, gives us a y value of 3. We get 0, 3. So let's see where we can use that here for a graph. If we want to graph this equation, we could turn it into y equals mx plus b form, but we don't need to. We can pretty simply find both intercepts. Okay, the x-intercept will have a y value of 0. That means this is just going to be 0. So we're going to get 3x equals 24, which when we divide both sides by 3 is x equals 8. Okay, and then if we want to get the y-intercept, okay, the y-intercept is going to have an x value of 0. 3 times 0, that's 0. Keep in mind here we're dividing by -4. Okay, we're going to have -4y equals 24. So when we divide both sides by -4, we're going to get y equals -6. So this equation that we have up here, we can graph pretty easily by just using these 2 points. We get an x-intercept of 8. That's the point right here. And then we get a y-intercept of -6. That's the point right here. So we have our 2 points, x-intercept, y-intercept. And then we could draw a line through them. Okay, so we could graph our line by going right through those 2 points. And there's the graph of that equation. We didn't have to turn into y equals mx plus b form. We could graph it right from standard form. So any of these forms we have are useful. Point slope form we could graph using the point and the slope. Okay, This standard form is particularly useful for finding the intercepts and using those to draw graphs or get other information where it might be useful to know what happens when one value or the other is equal to 0. So be comfortable with all these different forms. Know how they're all related. They're not separate equations or separate graphs. Okay? They're different ways of expressing the same equation or the same graph. I could write a point-slope form for this line that I have here. Okay? This line right here, I could write a point-slope form equation for that line. I could write a slope-intercept form for the equation of that line. And they would be the same line as I have here in standard form. Just different ways to express it. Sometimes one might be easier or more useful to work with than others, so we want to be comfortable with all of them.